good morning all. So today let us discuss about field force. Right? Now field force, already in my last lecture we talked about contact force. Force, it is divided into two categories: contact force, field force. So under contact force we discussed about tension, normal force, frictional force, muscular force. Right? Now before going for the field force, let us know what is field. So for that, this is a particular room. In this room, at one of the corner, I will keep a campfire, right? A corner. Now when I enter into the room, even though the fire is there at some corner, I feel hot. Immediately when I enter into the room, I feel hot. Actually fire is at corner. Then that heat produced by the fire must be limited up to that particular area. But is it happening? No. That particular heat produced from the fire is spreading up to a certain extent. Means here that space or region up to which the effect of that fire, the heat from the fire has its influence, we call it as field. So field is nothing but the space or region up to which the force is experienced. Right? If we enter into that particular space only, we feel heat. If I go away from that space, I will not feel any heat. For example, now only I said that at some corner I placed the fire camp. Now if I go outside, I will not feel any heat. But if I enter into the room, I will feel heat only due to the reason that it has extended its heat up to certain region. So that space or region, the space or region up to which force is experienced, we call it as field. Alright? Now such field force talks about that particular forces in which two bodies are not at all in physical contact to each other. So in contact force we talked that two bodies are in contact to each other. Okay, one body is exerting force on other body by having contact with it. Right? But here, if we take the two bodies A and B, they are not in contact with each other, but also A exert the force on B. Now B also exert the force on A. So such forces we call it as force at a distance. So when two bodies are not in contact with each other, such forces we call it as force at a hard distance. That we call it as a force at a hard distance. Now depending upon this, we are having three field forces. The first one is magnetic force. So in general life, or you may see the children playing, they will take a magnet. Okay. Now here, let this be the nails placed at certain distance from the magnet. We find that these all nails are attracted by this magnet. Actually there is no contact or physical interaction between these magnet and the nails, but also these nails are attracted by the magnet. Why? Means this magnet will have its effect up to certain region. You just see, with the small kids will play, when the nails come closer to the magnet they attract. If we go on moving these nails away from the magnet, they will not attract. Why they are not attracting means they went away from the field of magnetism, field produced by magnet. When they enter into the field produced by the magnet, so this is total field produced by the magnet. Means in this way I will find the magnetic effect. So when these nails enter into this field, this magnet is attracting that nails. So that force exerted by the magnet on the objects, we call it as magnetic force. Even though there is no physical attraction also, when the object enters into the field produced by the magnet, then automatically that object experiences a force of that magnet, and that force itself only we call it as magnetic force. Right? Now the second one is gravitational force. So any object, when it is dropped from certain height, what happens? It reaches the ground itself only. Why it is reaching it towards the ground? Why all objects are not floating and staying on the ground itself only, that is on the earth itself only? Only due to the reason that earth has certain force of attraction, the gravity force. That gravity force will try to attract all the objects towards the earth. So everywhere in the universe we see that all the objects are attracted towards the earth due to this gravitational force of attraction itself only. Okay. Now next step. The third one is electrostatic force. So this force is created between two charges. These charges may be like charges or unlike charges. If unlike charges, then these two will attract. We call it as electrostatic force of attraction. If both are like charges, same charges, they repel from each other, that we call it as electrostatic force of repulsion. So in such a way, field force is divided into magnetic force, gravitational force, electrostatic force. In these three examples, we find that objects are not in physical contact or interaction with each other. So they are at distance from each other. Then also, certain force acts by one object on other object. And the best example for that are magnetic force, gravitational force and electrostatic force. Alright. Now next, while writing the force, the main thing which we want to know is that about the direction. Because force, not only it has the magnitude, but also force has a direction. So while writing the forces, net force, especially net force, we have to consider the direction of force. Whether that all forces are acting in same direction or opposite direction. In such a way, we have to consider the direction and we have to write the net force. So what is net force? Net force is nothing but summation of all forces acting on the object. That we call it as net force. If F1, F2, so on are the number of forces acting on an object, then the summation of or algebraic sum of all the forces acting on an object, we call it as a net force. F1 plus F2 plus so on. Now next, equilibrium. When we will get equilibrium state? Equilibrium means what? Same state. Until the body is in motion, we will not find any equilibrium state. Here, on a body, this is the external applied force and this is the force applied in opposite direction. If both forces are in same magnitude and if they are opposite to each other, then body comes to the rest. Then we say that as both forces are of same magnitude and opposite to each other, body is in equilibrium. Right? Now next, another thing thing we have to know about the force is, if area of contact of a force or a load decreases, then effect of force increases. If area of contact of force or load decreases, then effect of force increases. So this is about the force which we talked in the first and second videos. The major problem we face in competitive physics exams is problematic part. Then how to solve this problematic part? Okay, he will give the problems. He will say to find out the force. Here, as we are talking about the force, I am taking the example of force itself only. So every time when you prepare for the exam, after completion of one particular topic in physics, just sort out all the formulas related to that particular topic. Just write down all the formulas. Okay. Now for example, in mechanics, what are the force examples? Newton's second law says force is equal to mass into acceleration. The same Newton's second law says that force is directly proportional to rate of change of linear momentum. Alright? So now next, not only like this, but in gravitational force, when you talk about the gravity, you must know about the gravitational force. Minus G m1 m2 by r square. So it is nothing but directly proportional to the product of masses, inversely proportional to the square of the distance between the two masses m1 and m2. And here gravitational force, it will be every time it is attractive force. The main thing you have to know that gravitational force is every time it is attractive force only, because m1 and m2 will be positive in all cases. Now next, here not only this, if we take for example electric field, how we will write the force? Actually here electric field, now this is the positive charge. Now already I said that this positive charge will have its effect up to certain region. The arrow lines which I am drawing indicates the direction of electric field produced by this charge plus Q charge. Now what happens if I place any test charge Q or Q naught in this field? What happens? This test charge experiences the force by this plus Q charge. So that force experienced by the test charge placed in the field of plus Q, we call it as electric field. So electric force can be written as electric field into test charge or unit positive charge. Alright. Now similarly, if you want to write the force in terms of magnetic field and velocity, now if this test charge is moving with a certain velocity v in the field, and if B is the magnetic field produced, now here I am drawing the magnetic field, these into marks are magnetic field, you think, let B be the magnetic field induction. If I introduce a charge in this magnetic field, now let V be the velocity through which this charge is moving, then 100% when electric charge is introduced in magnetic field, when electric charge is introduced in magnetic field, this magnet will apply certain force. So we find the charge is deflecting sideways. So when charge is traveling in magnetic field and deflecting sideways means nothing but magnetic force is acting on that particular charge. Due to that only the charge has deflected sideways in the field. So now considering all that, we can write QV cross B, where B is the magnetic field, V is the velocity with which charge is moving, Q is the charge of that particular charge, the magnitude of charge. Similarly, If we consider any cylinder moving with the magnetic field, we can write F is equal to, if I is the current flowing through this particular rectangular cross-sectional area, okay, L is the length of that particular cross-sectional area, B is the magnetic field applied, then it is written as BIL sin theta. This can also be written as QVB sin theta. So in such a way, we are having number of formulas in each and every topics, either electric field or magnetic field or mechanics or whatever it may be. These are only some of the force formulas which I explained here. So first, if we want to attempt a problem in a perfect way, read out the problem. First, read out the question perfectly. After reading out the question, you have to write down the parameters. So for example, if he asks to find the gravitational force, he will say that one mass is of 10 kg, other mass is of 20 kg, and it is separated by certain distance, 10 centimeter, etc. in such a way. Then what you have to do? First you have to read out the question. After reading out the question, you write down the parameters. What he said in the problem, he said M1 is of 10 kg, M2 is of 20 kg, and they are separated by 10 centimeter distance. After writing down the parameters, just think about that particular formula which relates these terms, right? Which relates these terms, and just write down, substitute the values in that formula and just solve that particular problem. Right? Now next, not only this, we will have pressure. So what is pressure? Pressure is nothing but force applied on particular area. We call it as pressure. Next, what are the units of force? Newtons. Right? You must know about the units also. Okay, so units of force are newtons. And what is the units for pressure? Newton per meter square, or after Pascal it is named as Pascal. In such a way, while preparing one particular topic, you must know about what is the topic, what is force, how many types of forces are there, in which way that forces will act. Force means nothing but changing, bringing a change in the position of the body, that is making the body to come out from the rest position, or making the body to deviate from the straight line motion. Then you must know about the formulas related to that particular topic. Okay, and also you must know about the units related to that particular topic. If you are perfect with all these things, then automatically physics become easy and you will be able to write the each and every question asked in the exam. Thank you.